Hey guys, welcome to the fifth lesson on fundamentals of C# programming. Today we're going to be talking about the basics of using methods. We're going to cover what a method is, how we create them, and why they are important to use. Alright, so what is a method? A method is simply a block of code that executes when you call that method and then thus creating an action. We've actually been using methods throughout all our lessons without you really knowing. For example, when we took in input from the console, we used the parse methods to convert the string representation to whatever type we were using. So, for example, if we said int my int equals int dot parse dot console.readline. This int.parse, this is our function or method. Method and function can be used interchangeably. They both mean the same thing. So this method, parse, is actually a method that was programmed for us, which is simply just a block of code that does an action. Um, this parse method has all the code required to take in a string and convert it into an integer. So that's all done for us, and then we just use the parse. We use the parse method, and then that code is done behind the scenes. So before we get started showing you how we create methods, one thing to note is because we're using console applications and we're dealing with the main method right now, since the main method is marked static, that means all the methods that we'll be building in this lesson and the next lesson will be marked as static. I'm not going to go over what static means until I start talking about classes, which is the following lesson. And in classes, I'll explain why we use static and why we don't use static. But for our purposes, static doesn't matter at the moment. But so for now, just when we build these methods, just make sure, just write down static and just ignore what it means. Just write it down so everything works, and then I'll eventually explain it when we talk about classes. Alright, so let's get started building methods. So first, let's note that this whole time we've been working on these console applications, we've been programming our code in a method this whole time. It's actually called the main method, and you can see the main method right here. Everything that is highlighted right now is a part of the main method. Um, the main method is a special method because it shows it's the entry point for the program. So um, for C# programs, the main method is where the execution of code begins always. So that's why when we run these console applications, the code always begins in between these blocks because it is the main method. So when we want to build our own custom methods, we're not going to build our method inside the main method because it already is a method. We're going to build our methods outside of the main method. So we're going to step out of the main method and go down here when we want to build our methods. So the first component that I'm going to cover with building a method is the access modifiers. Access modifiers we haven't seen yet, but simply access modifiers just um, tell the program what other classes and what other code can use this function or whatever is being marked with the access modifiers. So the two access modifiers that we're going to be talking about in the beginning, and obviously we will talk about them all in later lessons, well, the two basic ones are public and private. Public simply means that everyone and everything has access to it. Um, everything can use it, access it, and do whatever they want with it. Private means that the only things can use it that are within the same class. So as you can see, we're in a class called program. So if I make a method and mark it private, only things within the program class can use it. Other things in outside code can't access it and can't use it. Couple things to note about access modifiers. By default, methods are marked private if you don't explicitly uh, put in an access modifier. So, um, so because um, because methods by default are marked private, we're gonna just stick with using private for now. But I'm gonna explicitly write private from now on in our customly made methods. So that's the first component for creating a method is its access modifier. So I'm going to go ahead and write private because that's my first part. The next part of creating a, well, for us is going to be the static keyword. We're going to write static now. This can, however, the order can change depending on what you want, but I'm always going to write static next. Now, like I said, don't worry about what static means, but just write it for now and I will explain it in later lessons. But for our purposes, it doesn't really affect it too much. Um, the next thing after static is the method's return type. The method's return type simply just means when someone interacts and uses this our method or invokes our method, the return type shows or tells the caller what type of value could possibly or is possibly being returned from the method, meaning that if I were to call a method, some value could come back from that method to show something happened or something like that, which we'll get into. So just know the next thing is its return type. For our first method that we're going to create, we're going to mark this void, meaning there is no return type. Normally, when you mark something void, when you mark a method void, it means that you're going to call a method that's going to perform an action, and then that's it. Nothing gets sent back to the caller. So it just all stays within the method. That's what we're first going to do. Um, Other types of return types would be integers, doubles, or pretty much anything, any data type. When we get into more with data types, we'll see more other things, but for now, the basic intrinsic data types, which are int, doubles, bools, floats, all those, um, will be our return types. But for now, we'll leave it as void. And then after the return type comes the method's name. So the first method that we're going to build is a simple method that's just going to say hello to the console. So we'll name our method say hello. After the method's name comes the parameters of the method. The parameters of the method are simply just the requirements that the requirements of the method. The parameters just say, just tell the method or tell the user what the method requires in order for the method to accomplish its goal. So in our case, we just want to say hello to the console, so our method doesn't need any information from the caller. So we don't need to supply any parameters. So by doing that, we just denote that by putting an open and close parentheses. So that means that we have no parameters. So this line of code is our method header. This is our header of our method. Now that we have our header, we need to create our blocks for our method. Now that our blocks are created, any code that is in between these curly braces are a part of this method. So whenever this method is called, the code between these braces will get executed, thus causing an action. So let's just write a simple line, console.writeLine hello. So this is a very simple method. Once it's called, it executes console.writeLine hello, and yeah, this is the method definition of the method. It's very simple. Now, although we have our method definition now, If we were to run the program, nothing would happen. This is just a method definition. This is the outline of what happens when the method is called. But because we are not using the method, nothing happens. It's the same reason why when we want to parse something, we have to type out int.parse. It just doesn't automatically convert it. We have to say int.parse. It's the same reason why it doesn't automatically just say hello. So in order for us to call the function now that once it's defined, we can go back to the main method and just call the function by saying say hello and then open and close parentheses and then a semicolon. Nothing is inside the parentheses because, like I said, the function or the method doesn't require anything. So we don't supply any information. So if I were to run the program now, you'll see that the word hello is now shown into the console. Okay, so this is a very simple example that shows just one statement in a method and just displays the word hello. This method takes in no parameters. However, I want to modify this function now, or this method. I now want to add in one parameter for my method. I want to make it I want to make my method say to the console whatever the person who's calling the method, whatever they pass into it. So now, instead of always saying hello, my method needs some information. It needs the information from the caller, and that information is what the caller wants to display into the console. So in our parameters, we're going to put in what is required. So what's required is a string. Because in this case, we want the user to pass in a string, and then we will display it into the console. So in our parameters, we'll just say that we require a string, and then when they pass in that string will be represented in this method called sayHello as whatever I call it, and I'll call it just message. So now I'm saying my method sayHello requires the caller to give me, it requires the caller to supply this method a string, and when the caller supplies the method a string, that string will be represented as message inside of this block of code. So now instead of displaying hello, I'm just going to display message here. So now that I'm doing this, everything the method definition is complete. Now when I want to call the function now, however, I can no longer just say hello and open and close parentheses and then a semicolon. This error is because it's saying that the method requires more information in order for its task to be completed. So it's saying that it requires a string. So there's a couple things I could do here. I could just type in a literal string here, or I can make a string variable and pass that string variable in. In this case, I'm just going to make a string literal. And as you can see, when I open up the first parentheses for my function, it tells me what is required. It says it requires a string message. So I'll supply it a string message, and I'll just say hello world. Inside of it, close parentheses, and then a semicolon. Now that when I run the program, now it's going to say hello world to the console, because this is what happens. It goes say hello world. Hello world, this text as a string gets sent into this. It comes to here. Now this message, which is a local variable to this function, holds the value hello world, and then that value hello world is passed into console.writeLine. Console.writeLine is also a function itself. You can see that because of its parentheses. That shows it is a function. WriteLine takes in a string and then it does the code required to print it to the console. So this is an example of a function that takes in one parameter and displays a simple message to a console. Okay, now let's create another function. This time, let's make a function that takes in two parameters. In this function, we're going to make an adding function. This adding function is simply going to take in two parameters, two integers, and then it's going to add them and display the answer to the console. in the method itself. Our return type is still going to be void in this case. So to start off, we need our access modifier again. So we'll mark it private. And private, once again, means that only the things within this class can access it, and public means that everything can access it from any class and any outside code. So we marked it private. Next is the static keyword, which we are just copying for now. Then it's the return type, and once again, we're going to use void because everything's going to be staying in the method. The message is going to be displayed in the method. Then our method name, so I'm going to call it add in this case. And then in our parameters, or the things that the method requires from the caller, we're going to say it requires two integers. The first is going to be an int, I'll call it x, and then we put a comma to show the next one, and then we'll say int y. That says that we require two parameters of type integer. We'll create our body of our method, and then in our body we're simply gonna add our x and y together and then print it to the console. There's a couple ways we could do this. We could all do it inline, and we could make it all in the method code, or we can make a variable called answer. So it doesn't really matter. I'll just go int answer equals x plus y. So our answer is a variable that now holds the values of x plus y added together. Now I'm going to take our answer and print it into the console. So I'm going to use some placeholders. I'm going to go console.writeLine. Some placeholders. Let's say first placeholder plus second placeholder equals my third placeholder. The first placeholder will take the value of x. The second placeholder will get the value of y, and the third will be the answer. So now my add method is complete. It has 2 lines of code. We know that these 2 lines of code are a part of the method, once again, because they are in the block of the method. Now that we have our method definition done, now if we ever want to use this method, we can just call it in the main method or wherever we want to call it. So in this case, I'll go ahead and call it here. So I'll say add, and then I can pass in 2 literal integers. I'll say 5 and 10. So I go add 5 comma 10. Notice that my add function requires 2 parameters, so that's why I needed to supply it 2 parameters of type integer. It requires 2 ints, so I passed it 2 ints. I could store these integers into variables and then pass those variables. It doesn't really matter. But notice, if I try to remove the second one and just do add 5, once again I will get an error because my method requires 2 parameters in order to complete its task. So I'll put those back, and now I'll rerun the program. When the program runs, it says 5 plus 10 equals 15. So as you can see, 5 gets passed in and is stored into the variable x, in the parameter x. Then comma, and then 10 gets passed in, and then that's stored into y, which are its parameters. I then make a variable of x plus y added together that's stored into answer. So now answer has x plus y stored, so answer is holding the value 15 at the first line of code. Once console.writeLine runs, x and y are still 5 and 10, so that's put into the first placeholder. So x is the first placeholder and y is the second placeholder. And then equals the third placeholder, which is answer, which is also the value 15. So everything works out, and this is an example of creating a custom method to add 2 integers together and then display them into the console. Okay, so now let's take a little step up. We're still going to stay with return type as void and just single parameters, or a single parameter. And this time we're gonna make a little bit more realistic example of a function. So let's build a function now that will take in an amount of money and then times it by sales tax, or some kind of sales tax, and then it will display to the console the tax, like it will display a message showing the tax of a certain item. So to start off, we're going to build our function again. So we'll start with private static void display sales tax. And it's going to take in a double called sales amount. Okay, now in our body, we could do this several ways. I'm gonna make a constant variable that will hold our rate, our sales tax rate. So I'll go constant double rate equals 0.07, we'll say. And then we'll make another variable that will hold our tax, and we'll say our tax is equals to our sales amount times our rate. So now we have our tax, and then our simple console statement will be the tax on this amount of money is this. And then we'll use the placeholder method, and then we'll use some formatting to convert to currency format. So I'll say sales amount dot toString C. This is all from previous lessons. And then tax dot toString C. Okay, so now that that function is complete, now if we want to use the function, we simply call the function our main method, display sales tax, and then our amount. So I'll say $50. I'll run the program, and then we see the tax on $50 is $3.50. So this is just the same type of example of method that we've been doing, but now you can see a slightly more advanced method that shows some kind of realistic purposes in the real world. So this function actually could be used somewhere. Okay, so next thing we're going to talk about is now having different return types other than void. Um, And I'm also going to talk about a reason why we use functions and one reason why functions are important. So let's first create the function with the new type of return type and why we use this return type over the other way of doing a void. So for instance, we previously had a function called add that took in two integers and had a return type of void and displayed the answers into the console. So I'm going to recreate that old method that we had, and then I'm going to recreate it using return types to show you the differences and so on. So I'll create that method real fast. Private static void add int x int y. And then we had, what did we do? We had, int answer equals x plus y. And then we just did console.writeLine, first placeholder plus second placeholder equals third placeholder, and then x, y, answer. So we had this function. Now, this is a pretty decent function, but the problem arises when our caller needs our answer. So in this case, if I said add 5, 5, it would print to the console the answer is 10. But what if the caller, the person who's using this function, needs that 10? It needs to know what is the answer of 5 plus 5 so that it can then use that in maybe another function call or other kind of math calculations or other things that need to go on. It needs that answer. It needs the information back from the method. Now, this is okay if we just wanted to display the message to the console, but because there's going to be times that the caller wants information back, that's what the return type is for. So I'm going to recreate this function just using the return type instead of integer. So I'm going to make another one, private static. This time our return type is going to be an integer. because we're going to return the answer, which is an integer. I'll say new add is my new function, and it's going to be the same int x, int y. Now, instead of just displaying this, we're going to use what is called the return statement. The return statement says whatever you say return, that will send it back to the caller. So if I have int answer equals x plus y, and then go return answer, now answer, it will be sent back to the caller when they call new add. So now, as you can see in the new add function, there is no console output here. Everything is built. Everything. The answer is returned to the caller, and then the caller deals with the answer with however they want to deal with it. So, for instance, if I want like this and just a new add 5, 5, this is adding 5 and 5, and then it's being returned the value of 10. So when this is called, this is actually equal to the value of 10 now. But because we're not storing that into anywhere or remembering or doing some kind of using some kind of coding practice that we can store the information coming back from the method, that 10 is just lost. So in order to capture that 10 and store that so we can use it in other places, we can simply go int answer here equals new add 5, 5. Now when it goes new add 5, 5 here, it will go to my function, do 5, 5, it will get answer 5 plus 5, and then it will return answer back into the function call, which is here. So then this is equal to the value of 10. So this statement says int answer equals 10 in reality. So so now our answer variable holds the answer of 5 plus 5, whereas with this example, we don't know what the answer is. If I try to store that into a variable, let's say int x equals add 5, 5, 5, 5, now I'm using this function, I get an error because it's saying cannot implicitly convert type void to int. That's because the return type of add is void, which is no return type, and then I'm trying to assign that to an integer. So the only way to get information back from the method is to use a return type. Now that we have our answer stored, now if we wanted to just display to the console, we could display our answer here and display answer. So if I run the program, I will see that 10. But because we have the answer returned from the method, we could use this answer in other method calls. If I had other methods, I could then call those methods and with my answer back from the method. From this method. So just remember, return types help the caller get information back from the method and through the return statement. So when return answer happens here, that sends answer back to the caller. So when it goes return answer, that goes back to the caller. So I'm going to show you this with breakpoints. So I'm going to put a breakpoint there and then run the program. You'll see, okay, so the program starts out right at that method. As you can see, answer has a 0 right now. It doesn't have a value. Once I step into it, it goes into the method. Now this answer local variable has the value 10 stored into it. As you can see, answer 10, which is correct. We then say return answer. We step into it. Return answer then sends the 10 to this new add 5, 5. It comes back. Answer is still 0 at this point. And once I step into it, now answer is 10. Answer is now 10 because it came back from new new add 5 comma 5, and then that's stored into answer. So that was just to show you how the computer actually reads reads the code. Okay, now before I go on, I want to talk about one more thing. I want to talk about a concept of why methods are important and one reason why we use methods. Now, one reason is for code reusability. Um, there are times where we're programming stuff in a function, or in our case, the main method, for instance, and there are times that we'll duplicate an action. Let's say we wanted to add and then display to the console two numbers, but a couple of times. So if I said, okay, we don't have these functions, right? For example, pretend they're gone, and we wanted to do some adding and then displaying. So in our case, normally without functions, we'll be doing something like this. I don't know. Int answer one equals 5 plus 5. Console.writeLine answer 1. Int answer 2 equals 5 plus 6. Console.writeLine answer 2. Now this will go on and on. I can do it again. Answer 3 equals 15 plus 16. And now this is just to show you what would possibly happen. Obviously, if you were building a real program, there would probably be code in between these actions. There could be hundreds of lines of code in this function, and then these are just split up with different kinds of times that we need to add and display to the console. Now, because of this, we have code that's repeating itself. We have the same 3 lines we're displaying to the console, and we're adding. So there's a lot of code that's duplicating itself. So this is one reason why methods come in handy. Instead of doing this, I could then all group this into a function, and then the code repeating of the console.writeLine statement will go away. As you can see, if I bring my functions back into play here now, and I'll delete this function, I use my adding function. Instead of having these 3 console.writeLine statements, I can simply convert this into add 5 comma 5, add 5 comma 6, and add 15 comma 16. Now that we did it this way, we completely removed the problem of having duplicate lines of code, in our case console.writeLine. But you also may still be asking, why does it matter that we have duplicate lines of console.writeLine statements? And the reason is, if I bring this code back, let's say I have this code, right? And I'm just displaying my message into the console. We only have 3 in this example, but in a real world scenario, we could have hundreds of these, or dozens, or whatever. It doesn't really matter. We could have a lot of code replication. But let's say we wanted to, instead of just displaying answer 1, we wanted to then start displaying the answer is, and then concatenate and add the answer with using the placeholder method. So in this example, we would have to change all 3 of these. We would have to say, okay, the answer is placeholder, and then answer 1. Okay, we fixed the first one. Now we gotta fix the second one. We gotta put this answer 2. And then we gotta fix the third one, and we gotta put this answer 3. Now, as you can see, we had to go in and change each and every one because we wanted to change one of them. Because we wanted to change one of them, we had to change all of them. And that is the ultimate problem. That can take a lot of time if it's a bigger program and there's a lot of things we need to change. And it's just a pain in the neck. Whereas if we went back to using this method with adding, so add 5 comma 5, and we just did that for all these, watch this, 5 comma, I did 5 comma 6, and then 15 comma 16. If we did it this way, and then we wanted to change the output, instead of having to change it in each location, now we just have to change it in one location. So we wanted to show the answer is placeholder, comma, answer. Now that we did it this way, we only had to change the console statement one time, and all the functions that are using that all the function calls that are using this function are all changed automatically. And this could be hundreds or thousands of calls. Um, that we fix in just one line of code of change. Whereas if we used it without functions, we would have to change each and every one of them. So as you can see now, if we run the program, we see the answer is for all of them, and it's fixed for every single one. So this is one important reason why we use functions. Okay, so we talked about in this lesson how we create a function. We talk about what are access modifiers. We talk about what are return types, what are parameters. We created functions or methods that took in single parameters, multi-parameters. We created a function that had a return type of integer that took in two integers, added them together, and then returned the value to the caller so that the caller can do whatever the caller wants with that information rather than the function doing it. Um, Now, in this lesson, which is just an introductory to methods, that's all we're going to talk about with methods. But I have one more idea or concept that I want to go over with functions, and that is passing by value and passing by reference. Now I'm gonna show this in a couple of ways, but because this is only the first lesson on methods, I'm not gonna go into too much detail. The next lesson, which will be advanced method concepts, we'll talk more about this concept of passing by value and passing by reference, and talk about more advanced things with methods. This is just the basics of methods, just to get you familiar with them. So, okay, so let's just get started with the idea of pass by value. Before I explain pass by value, I'm gonna first demonstrate the differences between pass by value and pass by reference, and then I will explain them in a little bit more detail, but ultimately they'll be explained more in the next lesson. Um, So let's start off with simply just creating a, let's start off by creating a function that the function's job is simply to take in an integer that has no return type, so it will be void, and its job is just to add three to the integer and then print out the value of the integer. So to build that function, I'm going to go private static void. I'm going to call it add 3. Yeah, add 3. And it's going to take in an integer number. Inside of my function, I'm simply just going to go number plus equal 3 to add 3 to the integer value. Now I'm going to print out to the console saying inside the method, the x equals the value, number equals the value number. So I'm adding 3 to number and then printing what number is equal to with just this little line of code. I'm now gonna create a variable called number inside the main method, int number, and I'll say it's equal to 5. I'm now gonna print out to the console the value of number saying before method is called number equals number. I'm now gonna make a call to my function saying add 3 and then I'm gonna pass in number And then the last line, I'm going to reprint out, but I'm going to say after the method is called what number is equal to. So what I'm doing is I'm creating a memory location called number, setting the value equal to 5. I'm then passing that number into the add3 function, which then comes down to here. It takes the number, in our case, it's going to be 5. It adds 3 to that, and then prints it out here. Then when the code comes back up to here to add 3, it will continue down, and then it will print this out. What I'm trying to see what will happen is, after I call add 3, when it adds 3 to my variable down here, when it comes back, will my variable be affected in here? So we have int number here. Will this variable be affected in the main method because it was modified in the custom method? That is my question. So I'm going to run the function, I'm going to run the program, and we'll see what happens. Okay, I run the program. So it starts off by saying before method number is equal to 5, which is right. It calls add3 and then goes into the add3 function. It adds 3 to it and then prints inside method number equals 8. So it added 3 into the number variable and then displays it. But then I go after method number, so it comes back outside of the method and it goes after method number equals, and it says 5 again. Now, as we can see, the changing of the value in the custom method did not affect the original variable outside of the method. Now, this is because the concept of pass by value. When we are saying that of something is passed by value, we're saying that simply the value is just passed into the function. So when we go add 3 number, it's not passing in the variable itself in that memory location. It's rather just passing in the number 5, and then once it gets into this function, a copy of it is created and stored into this new variable called number. So when I this new variable called number that is unique to this function. Um, because we have a new variable here, when I increment this variable number plus 3, it changes inside of here, but this integer variable number here is not affected because we passed a copy into the function. So it's modifying its own copy of 5, adding 3 to it here, and then it does whatever it needs to in here, but like I said, nothing is affected in here. The number variable stays the same in here. So that is the concept of pass by value. Now I'm not going to go into too much yet, but by default, when you're passing things into functions, pass by value occurs to data types that are known as value types. So value types we'll talk about more, but just a quick brief overview. Value types for now are our intrinsic data types, so integers, doubles, floats, bools. Those are all value types. Um, they're value types because they are created as structures or structs. We'll talk about structs eventually, but just know that these basic intrinsic data types are value types. One other reason why they're value types is because um, they derive from a class called value type that makes them value type. But that's getting into some complex stuff. But so just note, integers and our basic intrinsic types are value types. So when we pass those into functions, they get passed by value. So staying with value types, I'm now gonna modify this a little bit and change this into an integer array. I want to say int array, my array equals, let's say 1, 5, 10, 15, and 20. So now we have an array that holds 5 elements. And we're gonna do the same exact program once again with just the first element of the array. So to do that, we'll say my array sub 0. That's the first element, which is simply an integer. We'll put it there and there. So now we're passing in the first element of the array. We're displaying the first element array, and we're displaying it here. But note, all separate elements of an integer array are just the type integer, which we know are now value types. So integers are value types. So just because we have an integer array, each individual element is still an integer. So if I run this, we see before method number equals 1, inside method number equals 4, so we added the 3, and then after method number it's back to 1. So that's exactly what we thought would happen. Because each element is an integer, this represents a single integer that's just grouped into an array. So the same thing happens. It passes a copy to the function modifies that copy, and when it comes back to the calling main method, um, the value is unchanged from the function. However, this differs. This process will change if I say now. If I let me delete this code for now. I'm gonna say now add 3, but my function now, instead of taking an integer, is gonna take in an integer array called my numbers. Now this is going to change. Now, instead of passing in an integer, we're passing in an integer array. Now, integer arrays or arrays can be considered reference types. A reference type, like a value type, um, are ways of storing data. Now, when we have a reference type, which is an array is a reference type, arrays get passed into functions by reference. They get passed by reference because they are reference types. Other types of reference types are classes. When we talk about classes, you'll see that those are also reference types. Okay, so let's just look at what happens when I pass in now, because our function requires an array of integers instead of just an integer. Now we're going to pass in our entire array into the function, my array. So in here, I'm just going to increment each element of the array by 3 instead. For that, I need to do a simple for loop. This is all from previous lessons, so everyone should know this. And then I'm going to go my numbers sub I plus equals 3. So I added 3 to all my elements of my array. And then instead, let me take out this and this. So I have it, I added 3. And then I'm going to display them, the values of the array, outside of the method in here. I'm going to display them here. So I'll go console.writeLine. My array sub I. So we're not going to do the in and out stuff. We're just going to print the values of the array outside of the method. So this should be either changed or unchanged. With value types, we saw that the values of the things were not affected by the function. So we'll go ahead and see what happens now. And when we print it out, we'll see that all the elements of the array were incremented by 3. So because this is a reference type, all the values of the array that were modified in here, they were at every element of the array got added 3 to it. Because of that, that this array is a reference type, all the values of the array that here in this integer array here were all affected. So that's why when I display all the values of the array inside the main method, they all show the new values. and that's because it's a reference type. You can think of a reference type when you pass a reference type into the function, rather than passing in the copy like the value types do. Reference types pass in the reference, or pass in a reference that refers to the memory that the original data was created. So when this integer array is created, it creates first a memory that resides on what is called the stack. Now we'll talk about this later on, but it first creates the variable which is stored onto the stack, and then it creates memory stored into the heap, which is the memory that can be accessed through the reference. So when we have that memory stored on the heap with reference types, we pass in the reference to the function that refers to that memory that's stored onto the heap, so that when it modifies it here, it's actually modifying the same information that this variable myArray here is accessing. You can think of this as one global memory spot, and that this variable myArray and this variable myNumbers down here both refer to the same exact memory location. So when this modifies that memory location, this also sees the changes. So like I said, this is just a quick example of value types versus reference types. Like I said, in the next lesson, which is advanced method concepts, we'll talk about more with passing by value and passing by reference in more complex scenarios. But yeah, so in this lesson we covered the basics of creating functions and methods. We talked about access modifiers, return types, parameters, and we've been using the keyword static in all our methods. And like I said, we don't have to worry about that now. Just keep on writing static in our methods. And when we do the lesson on classes, we'll explain what is the difference between static and non-static methods. Um, and yeah, so this is the basics of methods. So to finish up the lesson, we're gonna do a quick little simple exercise from the textbook that I used to teach teach these lessons. Um, here is the assignment. Okay, so the assignment says create a console-based program whose main method prompts the user for an integer value, and in turn passes the value to a method that squares the number and to a method that cubes the number. The cube method should call the square method. The main method displays the results returned from each of the other methods. So off the bat, we know that our methods cube and square um, are gonna have a return type because the numbers are returned to the main method, and then the main method displays it. It also says that we're going to call the functions separately, but when we use the cube function, we should use the square function to prevent or to use code reusability, because if you think about it, the cube function will have duplicate code that the square function already contains. The square function will times a number twice. The cube function will times it 3 times. So if we reuse the code from the square function inside the cube function, we only need to times it one more times after we call the square function, so that we don't have any duplicating code. So if you want to try this exercise now, pause the video here and try to do the program. Everything that I taught in this lesson should uh, prepare you enough to do this. But if you just want the solution, you can continue watching and I will go over that now. Okay, so it first says, I'm doing this now also, so it first says let's ask the user to enter an integer value. So So let's go ahead and write console.writeLine. Please enter a integer value. We'll store that integer value into an integer variable saying int value equals int.parse console.readLine. Now we have the value that was typed in converted from a string to an integer stored into our integer variable called value. Now that we have that, we need to create our functions before we can start calling them. So the first function we're going to create is the square function. The square function is going to be private static. It's going to have a return type of integer, I believe. Yeah. It's going to be a return type integer because, yeah, we're taking in integers. So we're going to return an integer. So, because the square of an integer is still going to be an integer. So we'll say our return type is integer, and then it would be called square, and then our parameters we're going to take in an integer called number, and that integer is going to be whatever was typed in. So now that we have that, we're going to create a variable called int answer, and well, the answer is going to be number times number, because that's simply squaring the number. So int answer equals number times number, and then we'll return answer. So our first function is created. The second function is going to be a cube function. So static is going to be the same thing, return int. Cube is going to take in an int number. However, this time the program asks us to reuse the square function so we don't have any code replication. So here we're going to call the square function, get that and store that into an answer, and then times that by another number for the cube part. So we'll make an int answer equals square passing in our number. So that will get us our number squared, and then we'll times that by another number. We'll times it by another number for the cube. So we reused our square function. This gets our value square, and then times it, and this gets cubed, and then that's stored into answer. And then we can return answer. So now our two functions are done. Now the program wants us to call each and then display each into the console. So let's first call the square function. So we'll use some concatenation. We'll put it all into the console statements. We could make separate variables and store them, and then let's make it easier for everyone. We'll make separate variables. So first is going to be our variable squared. So we'll make a variable called squared, and that's going to be equal to square, and then our value. Our value is whatever was typed in. So now we have our squared. Our our next variable will be cubed, and we'll say that's equal to cube times value. So now we have both our squared and cubed stored. Now we gotta simply just display it to the console. So we're gonna say console.writeLine placeholder times we'll display it. We can display this any way we want. We can just say squared or times itself. We'll say squared equals and then another placeholder, and then we'll plug in. So the first is gonna be value, and then squared. So that's our first console output. And then I'm gonna copy that, and then it's gonna be cubed, and then cubed. So this is the whole program. It's pretty simple. It uses the basics of functions. And let's run the program. We have please enter an integer value. So we'll first do 2. We got 2 squared is 4, and then 2 cubed is 8. Let's go ahead and run it again. Let's say 10. 10 squared is 100, which is true, 10 times 10, and then 10 cubed is 1,000, 10 times 10 times 10. So we can see that the program is working, and yeah, like I said, this is a pretty good example. It uses two functions with return types taken in parameters. We use some code reusability by calling our squared function in our cubed function because it uses some of the same code. So that so we don't replicate any code that is not necessary. And then we call each function. We store those into variables because they have return types. And then we display those values into the console. All right, so if you solved this on your own and got it working, that's a really good job. There are several ways to solve this. I could have solved this 10 other ways. I just did it this way to make it easy to read, and I don't know, there's just a lot of ways to do it. But that's going to be it for this lesson. Like I said, next lesson we'll cover some advanced method concepts, and then the lesson after that we'll talk about classes, or I'll talk about static and non-static, and then what classes are. So thank you for watching, and I hope you enjoyed.